Dear students, I would like to present to you the concept of the expected value of a random vector. Suppose that we have a random vector, capital X, and whenever we say random vector, capital X, we write it in bold face. ये generally acceptable है कि उसको bold कर दिया जाता है to convey that it is a vector. So I start again. Let capital X, bold, be a random vector given by two random variables, x1 and x2. Then the expected value of the vector x will exist if the expectations of x1 and x2 exist. अगर वो अलग अलग उनकी expectations exist कर रही हैं, then we say that the expected value of that vector also exists. And students, the formula or the expression is very interesting, as you can see now on the screen. The expected value of the random vector x is the vector of the expected values of x1 and x2. Isn't that interesting? I repeat, the expected value of a random vector is the vector of the expected values of those random variables. तो इसको लिए, let's take an example. Suppose that I toss two fair coins together using my right hand, and I define the random variable x1 as the number of heads that I obtain. Then, students, what will be the expected value of x1? Well, you can work it out using all the formulas that you know. I mean, the formula that you should apply in this case. लेकिन मैं आपको बताऊं, आप इसको बहुत जल्दी से भी कर सकते हैं. The expected value of x1 will be equal to 1. Why? देखें, आपने दो फेयर कॉइन्स को इकट्ठे टॉस किया है. अपने राइट हैंड से मैंने ये काम किया है. I can have head head, head tail, tail head and tail tail. तो उसमें अगर head head है तो x1 is equal to 2, क्योंकि x1 क्या चीज़ है? Number of heads. और अगर head tail है या tail head है तो x1 is equal to 1, क्योंकि head एक है उसमें भी और उसमें भी. And if you have tail tail, then x1 is equal to 0. Probabilities जो हैं, they are 1 by 4, 2 by 4 and 1 by 4. And because of these probabilities that I have just now shared with you, and you can find them yourself very quickly, you know that it is a symmetric distribution. And if it is a symmetric distribution, then the mean of that variable has to be at the exact center. So 0, 1, 2, the center is 1. ये क्यों हमने कहा कि probabilities are 1 by 4 and 2 by 4 and 1 by 4? इसलिए कि we are saying that those coins are fair. अगर fair हैं तभी आपको मालूम है कि आप 1 by 4 और ये सब कुछ कह सकते हैं. Now, suppose that with my left hand, I'm doing another experiment, and that is that I'm tossing a fair die. And I'm denoting the number that I get on the die on the uppermost face. This particular random variable I'm denoting by x2. If x2 denotes the number of dots that you have on the uppermost face of your die, students, what will be the expected value of x2? Again, you can do the calculations, but you should develop the skill to find it in your head very quickly and to be able to say that the expected value of x2 is equal to 3.5. अब ये मैंने कैसे कह दिया? Well, because I said that it is a fair die. अगर fair die है ना, तो फिर 1, 2, 3, 4, 5 और 6, ये जो 6 possible faces हैं, each one of them has probability 1/6. तो जब हर एक की probability 1/6 है, if it is a uniform distribution, discrete uniform distribution, again, if you draw its graph, you will be able to realize that if you put a mirror in the middle, the left-hand side is the mirror image of the right-hand side, and so it is symmetric, and therefore the mean or the expected value of this particular random variable has to be in the exact middle. So 1, 2, 3, 4, 5, 6, और 3 और 4 का middle 3.5. अब मैंने आपको x1 और उसकी एक्सपेक्टेड वैल्यू बता दी और x2 और उसकी एक्सपेक्टेड वैल्यू बता दी. ये अलग से एक्सपेरिमेंट किया था, ये अलग से किया था. But now suppose I am doing the two experiments simultaneously. एक हाथ से वो जिस वक्त फेंक रही हूँ, उसी वक्त दूसरे हाथ से डाई फेंक रही हूँ. So then, if you are considering these two variables, x1 and x2, together in the form of a random vector, then we can say that the expected value of the random vector x is equal to the vector e of x1, e of x2, and now that we have the numerical values of e of x1 and e of x2, 1 and 3.5, we can insert them there, and our final conclusion is that e of x, where x is the random vector, it is the vector 1, 3.5. This is how we proceed when we are wanting to determine the expected value of a random vector.